Welcome children. Today we are going to see class 9 maths. So in this session we are going to see chapter 2 polynomials. Okay, chapter 2 polynomials. In your earlier classes, I mean class 7 and 8, I hope you understood about polynomial based on the number of terms, based on number of terms alone. So here few more things we are going to see, and also based on that we are going to apply some identities, everything. So here proper definition we can give for polynomial. So just we can recall the previous classes concepts. First of all, expression, and then algebraic expression, and then only we can understand about polynomial. So this is a prior knowledge. What is expression? What is an algebraic expression? So first of all, expression means, for example, sum of 5 and 2. So we can write this as 5 plus 2. Sum of 5 and 2, which is nothing but 5 plus 2. So it's a simple expression. Clear? This is expression. Okay. So algebraic expression means algebraic expression. So that means if you face some variables, for example x minus 2 and then 2y plus 5. Okay, you see what's the difference from this and this? Here the unknowns x, y are present. So x minus 2 means, in words we can say 2 is subtracted from x, that is x minus 2. And this we can say twice y added with 5, or sum of twice y and 5, sum of 2 times y and 5. Like that, in different way we can say in words. So from words to algebraic expression. Okay, so we can give like this, and I hope you studied there in class 8 this and all. So this is expression and this is algebraic expression. What is algebraic expression means? If you find any variables, okay, x and y are variables here, and if I ask you what is variable, then many of the students are saying English alphabets are variables. That is wrong. Okay, English alphabets are used to denote the variable, that's all. So directly we cannot say English alphabets are variables. Okay, they are unknowns. We are using as unknowns. The English alphabets are used here as unknowns to denote the variable. So what is variable? What is constant? Variable means the word itself we find meaning, that is it varies. Okay, for example, x plus 3. This is an algebraic expression whose variable is x here. If you put 1 for x, what happens? 1 plus x equal to 1. So 1 plus 3 equal to 4. X equal to 2. 2 plus 3 equal to 5. X equal to minus 1. Then minus 1 plus 3. Minus 1 you put bracket to avoid confusion. Okay, for x we put minus 1. So minus 1 plus 3, minus 1 plus 3. That means nothing but 3 minus 1. Like that we can take this. 3 minus 1, which is nothing but 2. So like that, when we give different values for x, we get different solution of x plus 3. Clear? For x, if we substitute different value, then we get different solution. See, 4, 5, 2, like that. So that's called what? Variable. It varies for different values. It is not a fixed one. So here x is the variable. What about this 3? You see, in every step 3, 3, 3, that's never changed. Clear? So the fixed value, it's called constant. Constant. Clear? Constant means what? Fixed value. So variable means what? It varies for different value. Variables. Clear? Variable means here x is the one variable. Here you see y is the variable. Okay. So like that we can understand what is variable and what is constant. So if variable, constant and arithmetic operation, the combination of all these, what are they? The combination of variables, constants and arithmetic operations are called algebraic expression. Clear? So plus, so here minus, here plus. For example, if you give some other example, 9z minus 2. So here 9 is multiplied with z. 9 is, for example, you can take here 9z minus 2. You see here 9z, 9 into z. So it is multiplied. Okay, but no need to put multiple sign there. But you have to understand that it is 9z, 9 into z, and then minus 2 is there. So simply if you put 5x, then this is nothing but multiplication of 5 on x. Clear? So 5x. So multiplication. Or another example we can give as q divided by 2. You see here the division symbol is there. So this is also expression. So like that the operations are used. What operation? Arithmetic operation. Plus, minus, into and division. Okay. So all these four are arithmetic operations. So combination of variables, constants and arithmetic operations is called an algebraic expression. So up to this you know very well that we have already studied in classes 7, 8. So now polynomial also you have studied. What is polynomial? So what is different from algebraic expression and polynomial? So in your previous classes, polynomial means an algebraic expression is a polynomial, like that we have studied. But here we are going to see all the algebraic expressions are not polynomial. Clear? So we will see. So this is all explanation what we have read in the previous classes. So no need to take this. Okay. You no need to take notes this one. So now what is polynomial? So polynomial means x plus 2 a polynomial, y 2y minus 3 a polynomial. Okay. You see on all the polynomial x, y, like that the different variables are there. X plus y minus z means what? Here polynomial of 3 variables. Clear or not? So like everything is polynomial. And then x by 2 minus 5. You see x by 2 minus 5. It's a polynomial and algebraic. All are algebraic expressions. And you see 3 by x minus 2 by x. So you see this is the expression. Clear? 3 by x minus 2 by x plus 5 like that everyone you can take. So here it is also expression. All are expressions. Okay. But up to 4, okay, 4 expressions we can say polynomial. But this expression is not a polynomial. Why sir? Polynomial means, you see, you have to focus on the variable whose power means what? Exponent, whose exponent is a whole number. What? whole number. For example, if you take x square minus 2x, if you take like this, then the variable is x only here. Here the exponent of x is 2, which is a whole number. Here x is the variable and whose exponent is 1. So it is a whole number. So therefore, the exponent of each variable, okay, should be a whole number. That is the polynomial. But here, why sir, this is not a polynomial? This is not a polynomial. Why are you saying means this is nothing but the variable is in the denominator. So simply 3 by x means we can write as 3 into x power what? Minus 1. If you write in the straight way, avoiding the denominator, if you write like this, then this is nothing but 3 into x power minus 1. You know, the variable is x is in the denominator. If you take to the numerator, then the negative exponent will come. The positive exponent becomes negative exponent. So that we have read in the laws of exponents in the previous class. We have discussed that. Clear? So like that, here we can write this as 3 into x power minus 1. So that is the negative exponent is there for the variable x. So it is not a whole number. Whole number means what? 0, 1, 2, 3. These are the whole numbers. You know, whole numbers means 0, 1. Whole number is denoted by the capital letter W. Whole numbers 1, 2, 3, etc. So this is the whole number that you know. So the exponent of the variable should be whole number. Then only that expression, that algebraic expression is called a polynomial. This is a simple way. Clear? So now, a simple definition for polynomial: an algebraic expression having only the whole numbers as the exponents of the variable is called a polynomial. Example: p of x is equal to x square minus 2x plus 3. X square minus 2x plus 3. You see, here the variable is x, whose exponents are here 2, here 1. So 2x means that is x power 1. Okay. X power 1 is x only. So x square minus 2x plus 3. So the exponents of the variable x, only whole numbers. So this is a polynomial. Already I have explained to you. So we denote the polynomial whose variable in x is p of x. Suppose if it is another variable means y. So we can say q of y or p of y. So like that, depends on the variable. So we can name, and the letter also we can give differently. P, Q, again that means P of x, Q of y. So like that we can name. So the variable should be in the bracket. Okay. So now this is the simple definition of polynomial. So now coming to the classification of polynomials. So first, already have learned in the previous classes, based on terms. Based on terms means what? So you know how many terms here? 1, 2, 3. Yeah. Terms and coefficients, everything you know. So just I recall you. First you put the chapter 2 polynomial. Now only I am going to tell to take notes. So you put polynomial and take this definition and with the example. Clear? And then based on terms we are going to classify the polynomial first. So based on terms means number of terms we have to collect. And then the coefficients also is very important. The exercise maybe they ask the coefficients. So what is that we can see, but I am going to take this as an example. So here terms means here the terms are, what are they? Terms are x square and then minus 2x and then 3. Okay. Coefficients means coefficients. So I am going to write here. This is terms. Okay. Wait. you take this as terms, and here coefficients. You know that spelling, coefficients. Terms, coefficients. So what are the terms here in this polynomial? X square is one term, minus 2x. If minus is there, you have to take along with minus. So minus 2x and then 3. Okay. So you have to write the coefficients of all the 3 terms. So what is the coefficient of x square means? 1. Coefficient means the numerical value of each term. Okay, around that variable. Okay. So here x is the variable, but x square means this term. So before that, the numerical value with x square is 1. Okay. You don't say nothing is there. 1 is there. Okay. So 1 answer. Coefficient. Minus 2x. What is the coefficient of minus 2x term? That is minus 2, the numerical value. This is called numerical coefficient. Minus 2. And 3 means only 3 only. So no variable is there. So constant. So the constant system, the coefficient, that we can say. So like this, already you know in previous classes, terms and coefficients, the question will be there. So you have to write the terms of the given polynomial and the coefficients you have to write. Okay. And now, based on terms, monomial, binomial, trinomial. So you take all these first and then come to this side. This is monomial. A polynomial of one term is called a monomial. One term means you see x. X itself one term. 2y. I put comma. Separate. So 2y is separate. Polynomial. One term only. And here minus 5z. So minus sign is there, but minus, what is the coefficient of this minus 5z? Minus 5. Okay. So like this we have to take. Binomial. A polynomial of 2 terms is called a binomial. See here, 2 terms, x plus 5. So the 2 terms are connected by plus symbol. So x plus 5. So x is one term, 5 is another term. And you see here, minus y plus z. Here 2 variables are there. Anyhow, 2 terms. Minus y is one term, z is another term. So 2 terms are there. So it is binomial. P minus 5. So p is one term and minus 5 is another term. So therefore, these are 2 terms polynomial. So binomial. Trinomial. A polynomial of 3 terms is called a trinomial. Tri means what? 3. So mono means 1, bi means 2, tri means 3. Then you know. So according to that, the monomial, binomial, trinomial we are saying. A polynomial of 3 terms is called a trinomial. Example, x square minus 3x plus 5. You see, one term x square, another term minus 3x, another term 5. So totally, how many terms are there? 3 terms. And here, how many terms? 3 terms, x and then minus y and then 7. So these are the trinomial examples. So you take all these aspects. Clear? So this is based on number of terms. One more thing we can say, by, okay, this is monomial, binomial, trinomial. Based on that, if more terms comes, what is that? More than this, that means 4 terms, 5 terms, all are polynomials. So everything is polynomial. So this is specific. If there is only one term, it is that polynomial is monomial. Okay, you see the word starting is a polynomial. A polynomial means what? Everything is polynomial. If there is only one term, it is monomial. If there is 2 terms, binomial. If there is 3 terms, it is trinomial. More than that, we can say everything is a polynomial. If there is 4 terms, polynomial. 5 terms, polynomial. Like that, it proceeds. Okay. So this is the main concept about polynomial. And based on degree, we shall see. Clear? Based on degree. So based on degree, you see, based on degree, first of all you have to take what is degree of a polynomial. That is important. Then only you can understand based on the degree how to classify the polynomial. Degree of a polynomial is the highest power. What? The highest power of the variable. The highest power of the variable in a polynomial. is called what? Degree of the polynomial. Clear? So degree means the highest power of the variable in a polynomial is called degree. So example you can take x square. So you say 3x square minus 7x plus 5. You see here 3 terms, so trinomial, that also you can say then and there. So this is trinomial, and the highest power, you see here x is variable, here also x is variable, one variable, only one variable is there. So in that, which has the highest power? Here only. Okay, so here the power is 1, but you know x power 1 is x. Here the power is the exponent. Okay, that is x square means the 2. So this is what? Highest power of, let it be p of x. Highest power of p of x. In this polynomial I am taking here highest power of p of x equal to what? 2. Yeah. So the degree is therefore degree of p of x is also what? 2. Like that we can say. So degree means highest power of the variable in a polynomial. So now based on degree we are going to see the different polynomial. Clear? We take this. I will say based on the degree how to classify. So 1 degree, 2 degree, 3 degree, like that it goes. For example, a polynomial of degree 1 is called a linear polynomial. Okay, example x, we put 5x minus 3. Look here, based on terms there are 2 terms of binomial, but the degree, based on degree means, you see the variable of this polynomial is x and whose exponent is 1. So the polynomial of degree 1. So degree of this polynomial is what? 1. So degree means highest power. So highest power of the variable x here is 1. So it is called what? Linear polynomial. Linear means that you can take 1. Okay. Linear polynomial. Second one, a polynomial. Many examples you can take. 7y. So y, the polynomial in variable y. So there also what? Some y plus 8. Here also the variable is y and whose exponent is 1. So degree is 1. The highest power is 1. So degree is 1. And a polynomial of degree 2 is called a quadratic polynomial. The word quadratic, how to spell it? Look here, quadratic, Q-U-A, D-R-A-T-I-C, quadratic. Okay, quadratic polynomial means what? A polynomial of degree 2. Example, 3x square. That's all. 3x square means here only one term. 3x square is only one term, but the variable you have to focus. X is the variable and whose the power is 2. So therefore degree 2. The highest power is 2 only. Okay. So degree 2. So it is called what? Quadratic polynomial. Another example is 7y square minus 3y plus 2. See here, 3 terms are there, but based on degree, y is the variable whose power is 2, highest power is 2. Here the power is 1, so here the power is 2. So the degree 2, highest power is degree. So polynomial of degree 2 is called a quadratic polynomial. And then third one, a polynomial of degree 3 is called cubic polynomial. The words you have to remember. So this is linear for 1 degree, for 2 degree quadratic, and for 3 degree cubic polynomial. An example you can give: 5z cube minus 7. That's all. Here only 2 terms, but the variable is z, whose that is highest power is 3. So 3 is the degree of this 5z cube minus 7. The degree is 3. So therefore a polynomial of degree 3 is called a cubic polynomial. Clear? Suppose if 4 comes, degree 4 comes, so what is the name? So this is new to you. Okay. A polynomial of degree 4 is called biquadratic. You see the word biquadratic polynomial. So bi means 2. Okay. Quadratic means 2. You see here, a polynomial of degree 2 is called a quadratic polynomial, and bi is added with the word quadratic. Therefore 2 here 1 2 totally 4. So biquadratic polynomial. So a polynomial of degree 4 is called a biquadratic polynomial. Example, you can take 5x power 4 minus 3x cube plus 2x square plus 5x minus 9. You see 1, 2, 3, 4, 5 terms with descending powers starting from power 4, 4, 3, 2 and then 1. Here x alone, that means the power is 1 and the constant is minus 9. So how many terms? If you want to write all the terms, the possible terms 1, 2, 3, 4, 5. The possible number of terms, okay, is 5 when the degree is 4. Okay, when the degree is 3, the possible number of terms is what? 4. Here the degree is 4, therefore possible number of terms may be 5. Suppose any one term may miss here sometimes. For example, if you take alone 5x power 4, this alone is called what? Biquadratic polynomial. Already I have explained here. If there is only one term, that is 3x square, then also it is a degree 2, so therefore it is a quadratic polynomial. But which is must? The degree 2, the variable with degree 2 is must, then only we can say. So like that here, if you have only 5x power 4, it is a biquadratic polynomial because here also degree is 4. Sometimes minus 9. So 5x power 4 minus 9 alone present means, then also here that variable is x whose power is 4, that is highest power, the degree is 4. Therefore it is also a biquadratic polynomial. So though it have 2 terms, but the degree is 4, therefore it is a biquadratic polynomial. So everything is like that only. Okay. So depends on the degree, you have to focus on the highest power of the variable present in the given polynomial. So like that you have to understand. But an example is enough. Yeah. So this is based on degree. We are naming as 1 degree means linear, 2 degree means quadratic, and 3 degree means cubic, and 4 degree means biquadratic. More than that, okay, you have to say the number. Suppose degree, highest power is 5 means then the degree of the polynomial is 5. So 5 degree polynomial, 6 degree polynomial, 7 degree polynomial, like that you have to proceed. So up to this a specific name is there. So more than that you have to say like that. Okay, depends on the degree you have to name. So like that. So now let us see exercise what? 2.1. It's a very simple exercise. Okay. And you know now we have discussed what is the terms. So variable, constant, expression, algebraic expression, and then terms, coefficients. That is very important. How many terms present and what is the coefficient or numerical coefficient of every term in a given polynomial. Okay, terms, coefficients, that you know. And then degree of the polynomial. Okay, based on number of terms we can classify the polynomial. Based on number of degree, okay, based on the degree we can classify the polynomial. So both you don't confuse. Based on terms a separate name is there. Based on degree a separate name is there. Don't confuse. Clear? And now we are going to see degree of a non-zero constant polynomial. Okay, note. You take this as note. So everything have to take notes. Okay. So note. A degree. Wait. The degree of a non-zero constant polynomial. The degree of a non-zero constant polynomial is 0. 0 means the number 0. So example we can do. Example. So let p of x is a polynomial. The polynomial is simply I am writing as 7. Number 7 alone. So number 7 means what? Constant polynomial. Why we are saying that constant polynomial? Constant polynomial means there is no variable. Only what? Non-zero constant. What is non-zero constant means? If it is 0, then it is called zero polynomial. Okay. So this is what? Non-zero polynomial. Except 0, the other numbers we can say that is non-zero constant polynomial. So this is called constant polynomial. Okay. Without 0 means if it is 0, it is 0 polynomial. If it is any constant other than that 0, then it is called non-zero constant polynomial and whose degree is 0. So why we are saying that degree is 0? Can you say? This is 1 point. Okay. 7 you can write as, this is explanation I am giving. 7 you can write as 7x power 0. Reason you have to take as a reason. Okay. Reason. 7 you can write as 7x power 0. 7 we can write as 7 into x power 0 or 7 into y power 0. So like that everything we can write. Why? Because any number or any variable whose exponent is 0, the value is 1, that we know. So this is what? 7 into 1. This is what? 7 into 1. Y power 0 is 1. So anything power 0 means 1. So we can write in any way. Yes or no? Any way you can write. So any variable you can use, but exponent should be 0. Then this is called what? The degree is 0. If it is x square, then we can say the degree is 2. If it is y cube, then we can say the degree is 3. That is the highest power 3. But here x power 0, y power 0, any variable with power 0. We can say for any non-zero constant. So I take here 7 as a constant. So 7 you can write as 7 into x power 0, 7 into y power 0. So anyway you can write. But the exponent should be 0. So therefore x power 0 is 1. So 7 into 1 is 7 only. So we are saying the degree is 0. Okay. So any form we can write. Not only this, any form, etc. Okay. Any variable you can use, but exponent you have to write as 0. Then only you can get 1. So that's the reason why we are saying the degree of a non-zero constant polynomial is 0. Here. So now, proper definition for a general definition for polynomial. So previously we have seen that polynomial means the exponent of the variable present in the given polynomial should be whole number. The exponent of the variable should be whole number. That is the polynomial. Okay. Now, in algebraic way, we can see that is oral definition in words. So here you see a polynomial in one variable x. We are taking a polynomial in only one variable. X means x, y means y. That's all. No other variable. Okay. So in a polynomial in one variable x, you see x I have taken as the one variable. Of degree n means what? Any degree. The degree n means what? Any degree, any number. Degree 4, degree 5, degree 6, like that. Anyway, degree n is an expression. It's an expression of the form. In which form it should be? You see, I am naming a polynomial as p of x equal to an x power n plus an minus 1 x power n minus 1 plus etc. plus a1x plus a naught. That means what? You see, an minus 1, everything up to a naught are nothing but numerical coefficients or constants, you can say. Constants. So where a naught, a1, etc. up to an are constants, and the condition is an not equal to 0. An means what? Which is the coefficient of x power n. So x power n only the highest power. Here you see, here the power is n, here n minus 1. So the power is descending. So here you see a1 x, that means x power 1. So here a naught means what? That is the constant without variable. So that means what? A naught means we can understand like this: a naught x power 0. You should not read this as a0. That is different. So this is 0 only, but here to avoid confusion we have to read as a naught. So a naught x power 0. So which is nothing but x power 0 is 1, that we know. So again a naught only it will come. Clear? So only we are writing here that a naught alone. Okay, this is the proper way. So you have to understand the hidden meanings and all. So an should not be 0. Why we are saying? Because if an becomes 0, then the whole an x power 0 into x power n becomes 0. So therefore the degree will change. Therefore x power n term, nth degree will not come. The next only will come. If an becomes 0, this whole term becomes 0. 0 into anything is 0. So only the condition is given that an equal, which is not equal to 0. Clear? So this is the condition. Other any term may be 0 or any term can be. I already told you x cube plus 2x minus 2. If 2x is not there, then also it is a degree 3 polynomial. I explained you. So in such a way you have to understand this is a general form. Clear? And one more point you have to see. If the coefficients means what? The numerical constants. For example, here the constant that is an. Okay, like that. You can say coefficients also. If every coefficient or every constant is 0, with including a naught, everything is 0, then the whole polynomial becomes 0 only. Everything an 0 means x power n term will not there. An minus 1 is a coefficient or a constant. If it is 0 means then x power n minus 1 will not come. So if every constant becomes 0, then you get only 0. So that is we get p of x equal to 0. Now 0 is a 0 polynomial. 0 is called a 0 polynomial. Clear? If it is non-zero, non-zero means what? Other than 0. 5, minus 2, 11, okay, 25. So these are non-zero. So non-zero is nothing but constant polynomial. Clear? Already I told you, non-zero constant polynomial. Other than 0, everything is constant polynomial. So now there we see the degree of the constant polynomial is what? 0. Clear? Because if 5 is a constant polynomial means, then we can write this as 5 into either variable x power 0 or any variable you can put, but the exponent should be 0. Then x power 0 is 1, therefore 5 into 1 5. So like that you have to understand clearly. So now coming to this 0 polynomial, what is the degree? Degree of the constant polynomial is what? 0. But what is the degree of a 0 polynomial means not defined, because the explanation I have given here, p of x is a polynomial, that is 0 polynomial. So 0 you can write as 0 into x cube, 0 into x power 100, so 0 into x power 1000. So anyway if you write 0 only comes. Multiple with 0, 0 only answer. So degree is not defined. We can say any degree, so it is not defined. Clear? So now we move to exercise 2.1. Very easy, you can answer by yourself. Very easy exercise. The first one, exercise 2.1. You see what is there? First sum. Which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. So first option, you see what is there. First option, 4x square minus 3x plus 7. 4x square minus 3x plus 7. So here we have to say whether the following expressions are polynomial in one variable and not. And you have to say the reason also. You see here x only the variable. So it is polynomial one variable. You have to write the expression is what? The expression is a polynomial in one variable. That variable is what? X alone used there. Option 2. You see y square plus root 2. So this also the same answer. The expression is a polynomial in one variable. You see y is the variable used here. Y square plus root 2. Root 2 is also a constant. If it is coming root, but it is number only, so root 2 is a constant. Y square plus root 2. So the same answer you have to write. Here the same answer. Option 3. What is there? 3 root of t plus t root 2. T root 2. Clear? So third option you see, the variable has root inside the root, and here simply t, but the constant is in root. Okay. But is this a polynomial? Can you say? No. Why? You see, a polynomial means the exponent of the variable should be a whole number. But here, this root t you can write as t power 1 by 2. By applying the law of exponents, we can write this root t as t power 1 by 2. So therefore, this is the 1 by 2 is not a whole number. Therefore, it is not a polynomial first of all. Okay. So as per the definition of a polynomial, this expression is not a, this is the expression. This is an algebraic expression but not a polynomial. So it is not a polynomial because it is not a, first of all it is not a polynomial. If it is a polynomial, then only we can say it is either one variable or not. But it is not a polynomial since exponent of the variable, since the exponent of t is not a whole number. T means what? The variable used there. T. Single stop I have used here. So t, within quotation I have put that. So t is not, the variable t is not a whole number. The exponent of the variable t is not a whole number. I have given single quotation. You don't take the t power 1 and all. Single quotation I have given. The variable t, no, the exponent of the variable t is not a whole number. That is the reason why we are saying this is not a polynomial. Like that we can understand all these things. You see, just orally I will tell you, take as homework. Option 4, y plus 2 by y. Option 4 is y plus 2 by y. Here 2 by y means y is in the denominator, therefore y power minus 1 will come. So here also the same answer you have to take. It is not a polynomial since the exponent of the variable, or instead of t you can see variable, you can write exponent of the variable is not a whole number. The same answer you have to write for this. Okay, here the variable is y, but the exponent is not a whole number. And then coming to the next one, x power 10 plus y cube plus t power 50. So for that we have to take, it is not a polynomial in one variable. You see, x, y, t. So 3 variables are used there, but it is a polynomial. Clear? You see, option 5. What is that? X power 10 plus y cube plus p power 50. So either the power is more, but it is a polynomial, but not in one variable. It is a polynomial of 3 variables. It is a polynomial in 3 variables, not in one variable. Clear? X, y, t or 3 variables. That's all, option 1. And coming to question number 2, write the coefficients of x square in each of the following. So I will do the option 3. Okay, I will just write all the options, but you have to do as homework. Second question, option 1, 2 plus x square plus x. So simple answer. Okay, the objective answer like that. So x square coefficient they are asking. What is the x square coefficient? It is the x square term. So coefficient of x square is 1. You have to write coefficient of x square is 1. Okay. Option 2. Can you say 2 minus x square plus x cube? You see, option 2 is 2 minus x square plus x cube. So here, what is the coefficient of x square? Minus 1, because minus sign is there. So including the sign, you have to tell the coefficient. So the coefficient of x square is minus 1 here. So you have to write that as homework. Option 3, pi by 2 x square plus x. So here the coefficient of x square is pi by 2. So pi by 2 is nothing but the value. Here x square coefficient is pi by 2. You have to write answer, coefficient of. Okay. X square equal to pi by 2. The answer is pi by 2. Coefficient of x square is pi by 2. So like that, option 4 you take as homework. But you have to understand what is there. Option 4. What is given there? Root 2 x minus 1. So here no x square term. Here x square term is missing. Therefore they are asking coefficient of x square only. Therefore here 0 into x square. Clear or not? So the coefficient is what? Here is 0 because no x square term is there. So you have to write the coefficient of x square is 0. If you write 0 into x square, that is right. Clear? So you have to write like this: 0 into x square plus root 2 x minus 1. So what is the coefficient of x square? 0. Like that we can understand. Clear? And now we shall go to the next sum. Third one, give one example each of the binomial of degree 35. So this is not very easy. So degree 35. So first answer you can give as option 1. So degree 35 example means 5x power 35. Any example you can give plus 7. Clear? So degree should be 35 means, but the binomial means what? 2 terms. So you have to focus on number of terms and also the degree. Here the binomial is asked. So binomial means 2 terms, but degree also 35. So you have to take in mind that. So 2 terms and x is the variable whose highest power, that is degree, is 35. This is one example. Clear? Any such examples you can give answer. Give us answer here. In option 2 you see monomial of degree 100. Monomial of degree 100. So you can give 3 into x power 100. So only one term is there and whose degree is 100. So one term is monomial and the highest power, that is degree, is 100. Therefore it is a monomial of degree 100. So many such examples you can give. Clear? And fourth one, very easy exercise. Write the degree of each of the following polynomials. You see, first one, just degree only they are asking. 5x cubed plus 4x square and then plus 7x. So you see here the variables are in x only and the degree highest power is 3. Clear? The variable exponent we have to see which is the highest power. So 3. So degree is 3. That's the answer. So option 2. So what is that? 4 minus y square. So the degree is 2 because the variable is y whose degree is 2. So the answer degree is 2. Clear? So like that we have to take as formula, very simple. And the next one, 5t minus root 7. So 5t, so t is the variable. Therefore 5t minus root 7. But this is the variable. Okay, t is the variable whose degree is 1. So the answer degree is 1. Clear? The highest power of the variable t is 1. So degree is 1. And next one, 3 alone given. You see the option 4. 3 alone they have given. So 3 is a polynomial. What polynomial? Constant polynomial. If it is 0, 0 polynomial. If it is 0, 0 polynomial. But other than 0, that is called non-zero. So this is non-zero constant polynomial. Okay. So for constant polynomial degree is what? 0 because we can write 3 as what? 3 into x power 0 or 3 into z power 0. So any variable with power 0 we can write the constant polynomial. So the degree of the constant polynomial is always 0 because 3 into 1 3. Here also 3 into 1 3. So like that the degree of the, you can write degree of 3 is what? 0 because the variable possesses the power 0. So you have to write degree of 3 is 0. That's all. And now coming to question number 5. Question number 5. So what is there? Classify the following as linear, quadratic and cubic. Okay. 7 options are there. So you yourself can do this. But even though I am telling that x square plus x. Option 2. This is question number 5. X minus x cube. Option 3. You are going to say this. Y plus y square plus 4. And then option 4. 1 plus x. Option 5. 3t. So option 6 and 7 you do by yourself. But here up to 5. So this is, you have to classify based on the given polynomial. Linear, quadratic, cubic. So linear means degree 1. Quadratic means degree 2. Cubic means degree 3. That you know. So here the degree is 2. Therefore it is quadratic. Okay. So this is quadratic. Quadratic means quadratic polynomial. And here you see x minus x cube. What is the degree? 3. So therefore it is cubic polynomial. The highest power you have to notify. Here x variable, the highest power is 3, that is the degree. So degree 3 means cubic polynomial. And here y is the variable and the degree is 2, therefore quadratic. We don't point out only the first variable. Okay, the first term alone you don't find. You have to see all the terms and where is the highest power, where that is the degree. So here the second term is y square. So degree 2, therefore quadratic. And here 1 plus x. So 1 plus x means x is a variable whose degree is 1, therefore linear polynomial. And this one 3t, t is the variable. T is the variable whose degree is 1, therefore this is also linear polynomial. And the rest of the two sums we take as common. Thank you, children. Up to 2.1 is over, and worksheet will be regarding 2.1 will be sent to you. Finish it then and there. Thank you.